Just like precision, we have another quantity that is called recoil. The recoil is the number of true positives divided by the number of true positives plus false negatives. Let's quickly look at our confusion matrix again. In this case, we are taking the true positives and dividing by the sum of true positives and false negatives. If you remember the definition of sensitivity, you will see that recoil is the same quantity as sensitivity. The reason we have two different names for the same quantity is a consequence of how the entire field of model building was developed through many different fields and disciplines, and only recently we are beginning to consolidate the terminology. So usually if you look at statistics books, you will see the terminology of sensitivity, while if you look at a machine learning book, you will probably find the word recoil. Also, when we are comparing with specificity, we tend to use the word sensitivity. When we are comparing with precision, we try to use the word recoil. Mathematically, they are the same quantity. Also remember, as we varied our threshold, we had different values of sensitivity and specificity. In the same way, we can get different values of precision and recoil by changing our threshold or cut. The resulting curve is very similar to our ROC curves. In this case, these curves are called precision recoil curves. Let's go back to our IPython notebook. We had already built our models and we had received some accuracy numbers for the given classifiers. Let's look at this piece of code. When you run this piece of code, you will get the following table. Now we have the same kind of confusion matrix that we had before. Let's look at the next piece of code. Here we are using this method of plot precision recoil curve to plot a precision recoil curve. We're using the scikit-learns method to actually calculate the values of precision recoil for every cut. Let's run this piece of code now. The next line should actually draw the curves for you. If everything runs properly, you should get a curve that looks like this. In this case, the recoil has been plotted on the x-axis and the precision on the y-axis. Remember, the values of both range from 0 to 1. In this case, the logistic regression, the random forest classifier, and the support vector classifiers are shown in blue, green, and red respectively. We have also calculated the area under the curves for each of these precision recoil curves. This gives us an average measure of performance for these classifiers. It is often useful to use the PR plot if we are interested in the proportion of positive outcomes over the negative ones.